All right, we're talking about piecewise functions today. You can find piecewise functions in section, or I think it's called lesson 2.6 in your Algebra 2 textbook if you want a little bit of background information, but I'm going to kind of give you the gist of it here. Piecewise function is a function that is defined differently on different intervals. So when you look at these functions, they look kind of messy, right? It's like f of x equals this, f of x equals this, and there's this other, inequality stuff. So like, what's going on here? Well, basically what you have here is you have two different equations and two different intervals. All right, so let's look at number 3 really quick, and I'll get you started on this. This section, what I would do is I would just kind of maybe like divide this section up. This is talking about domain, where your graph is going to live. Okay, let me zoom in a little bit so you can see that. So domain is where to make this graph. Okay, now you have two equations here, and this is the function equation, and so this is like what to graph. So I have what and I have where. Okay, notice there's two of them. So the first thing I always do here is I always just like break up my domain. So step 1, break up the domain. Okay, so notice if I'm just looking at the domain, I have two sections. I have the section where x is greater than or equal to 0, and I have the section where x is less than 0. So this side of the graph is the side of the graph where x is greater than 0. So I'm going to put like a line here. Now of course there's already the y-axis here. But on the right-hand side of the y-axis, I'm living in this section. And on the left side of the axis, I'm in this section. So this is all the stuff where x is greater than 0. This is all the stuff where x is less than 0. So two different spots where my graph's going to live. So what this is saying is in this section of the graph, use this equation. In this section of the graph, use this equation. Okay? So what I like to do next is I like to list out the equations I'm going to graph. So list functions to graph. All right, in this case I have two of them. I have negative x plus 4 and I have x squared. Now this notation is kind of tricky. It's like f of x equals this function for this domain or this function for this domain. So to kind of like make it a little bit easier for me to process what's happening, I like to write them in y notation. So I'm going to graph y equals negative x plus 4, and I'm also going to graph x squared, y equals x squared. Okay? Step 3, what I'm going to do is I'm going to graph each function one at a time and then erase the part that I don't need. Because remember, like these graphs only live in a specific area. This area of the domain is what tells you that. So graph each function is step 3. I like to do it one at a time. Okay, and then after you graph each function, before you start graphing the next one, what you're going to do is you're going to erase the parts of the graph that are outside your domain or outside your interval. Okay, erase the parts that are outside your interval. So let's see how that's going to look. Let's start with this equation. Okay, well this is a linear equation, right? It kind of looks like y equals mx plus b. So if you go way back, reach into your memory and go way back to 8th and 9th grade, slope-intercept form is written like this, and this is the slope and this is the intercept of your graph. So this guy's a linear function and the y-intercept is 4. Okay, so I'm going to start my graph at 4. Now I'm going to use a pencil here because I'm going to have to erase. So I'm going to start at positive 4. Okay. And then I needed my slope. So if I look at the number in front of x, in this case I don't see a number, but that would be like a negative 1 x. So negative 1 means to go down 1, right 1. So this has a slope of negative 1. Okay, so something like that. All right, now I'm going to connect the dots to make my function. Sorry, I had a straight edge over here for a second ago and I misplaced it. I'll use this thing. All right, so my graph of my linear function looks like, make sure I line it up right, this. Okay. Now what I'm going to do is I'm going to go back and erase the part where it's not supposed to be. Okay, so I'm going to see where it lives. Now this function is only supposed to live where x is less than or equal to 0. That's on this side of the graph. So it's not supposed to live on the right side, it's only supposed to live on the left side. Okay, cool. Now I'm going to go back and do it again. So go back to step 2, and I need to graph y equals x squared, right? So in order to graph some of these, you're going to have to know what these functions look like, okay? Now, I have this guy here, graphs of basic functions, my handy-dandy reference sheet. I passed this out in class, and it was kind of a homework assignment. I mean, it wasn't for points, but I told you it was something you're going to need for future assignments, and this is one of the assignments you needed on. So if you have not done this yet, you should do this first. Okay, there's some instructions in Canvas. I gave this last week, so go find this in Canvas for last week and familiarize yourself with these different functions because you're going to have to know how to graph them. Okay, now when you fill this guy out, you can use Desmos to help you out, and I show you how to do that in that video, or I think I posted a video. So go to that assignment, and there'll be some instructions for you. But on like a test or a quiz or whatever, we don't want to use Desmos. We don't want to become reliant on it and use it as a crutch. So we are going to we're going to use this guy. I'll let you use this on your tests and quizzes, but not Desmos. So you need to kind of get familiar with these shapes. So notice f of x equals x squared or y equals x squared. It's this shape. It's a parabola, and I even got some points here that I can use. So this is the shape that I want on this graph, right? Y equals x squared. Okay, we know what that looks like. So it's got this point here, and this point here, and this point here. 0, 0, 1, 1. It's got the point 2, 4, and it's got the point 3, 9, which is off the charts. And then I would also normally do it on this side. Okay, so the graph looks like this. But remember, this is saying only graph this part on the right side of the graph. Okay, so I'm going to come back and erase this. Okay, and there's my graph. Now there's one more step here, and that's we have to figure out what happens here. Remember that if a function, if a line can cross a function twice, a vertical line, it's actually not a function. It's the vertical line test. So I'm not allowed to have a point here and here. I got to figure out which one to use. So if I go back to my intervals here, the pieces of the domain that I'm going to use, this interval includes 0, right? Because this is x is less than or equal to 0, and this one doesn't include the 0 because this is just x greater than 0. So I have to figure out, does the left-hand side own that point, or does the right-hand side own that point? And it turns out that the left-hand side owns that point because of the line under that inequality symbol. So I can't have a point here and here. I'm going to have to erase this point, and instead of a point, I'm going to put an open dot. Okay, so that's a piecewise function. It's defined as a linear function on the left-hand side, and it's defined as a quadratic function on the right-hand side. Okay, let's look at another one here. Okay, let's take a look at maybe one of the ones that has 3 different sections. Okay, so number 10. Again, I always start with my domain. I want to break up my domain into sections. I got the x is less than -4 section over here. I got the x is between -4 and 1 section, so this actually has 3 sections. So that's right here between -4 and 1. And then I have the bigger than 1 section. So I kind of don't have a lot of space here, so I'll put -4 less than or equal to x less than or equal to 1. Okay, so those are the 3 sections that I'm going to use. Okay, those aren't part of my graph. Those are just the places where I'm going to graph. So there's going to be a graph over here, there's going to be a graph over here, and there's going to be a graph over here. Okay, that's my first step. My second step is to write out my 3 functions that I'm going to graph. So I have y equals 2, I have y equals square root of x, and I have y equals 3. Okay, So y equals 2 is a horizontal line that is just, it's flat and it goes this way. Okay, so that's y equals 2. That's what it looks like. Okay, now I got to figure out where that lives. It only lives in this section. So I graphed it, right? I can see that it goes through 2, and that's all well and good. But now I can come back and kind of get rid of this stuff here and get rid of this stuff here. All right, so that's where the first part is. Okay, next I have y equals the absolute value of x. And that's from this section to this section. So again, I'm going to jump in here and look at my table, or my graphs of basic functions reference sheet, and it looks like a V, right? And I know I have these points here. So let's kind of see what that looks like on our graph, right? Got the point 0, 0, got the point 1, 1, I got the point 2, 2, I got this guy, I got this guy, I got this guy. So that's what my graph looks like. So I always like to do the graph first and then come back and erase. Because if I just try to do it like, try to think about what it's going to look like and try to predict, I always kind of get it wrong. So graph first, then go back and erase. This graph lives in this section. So we're going to go back and get rid of this stuff. Don't need any of that. I'm going to go get back and get rid of this stuff. Okay, so that one's done. And now we have y equals 3. Okay, so that looks like this, horizontal line. Now normally this would go all the way across, right? But we're not going to use it here or here. Okay, so I'm going to come back and pen here and clean this one up. But we also have to know which parts of the domain own the coordinates here. So like I can't put a point here and a point here. That doesn't work. I can't put a point here and a point here. That would be not a function. So which one owns -4? Which of these sections of the domain includes -4? Because of the greater than or equal to symbol here, or the less than or equal to symbol, and the less than or equal to symbol, this one includes both of these guys. So the middle graph owns the coordinates here and here. Okay, -4 is included in the middle section, and 1 is included in the middle section. -4 is not included over here, so I need an open dot, and I need an open dot. Okay, and then I'm going to fill this guy in, and this guy, and this guy. Alright, that's my piecewise function. Now keep in mind that these other lines that I drew, they're not really part of the graph. They're just kind of helping me define my domain. So that was a little bit smeary. Anyway, so you get the idea. That's a piecewise function there. It's in sections. Okay. Alright, let's look at the last two here. I'll get you started on those. So this notation is probably new for you because this is something that we haven't talked about in this class yet. These are different operations that we haven't seen. This one right here is what we call the floor function, and this one right here is called the ceiling function. So before we graph these guys that are a little bit, there's an extra piece to it, let's just go back to the basics and talk about those different functions. So let's start off with the floor function. Okay, so f of x equals, whoops, start over. F of x is equal to this thing. Okay, now this special kind of bracket means round down, which is why this is called the floor function. Okay, so I'm going to make a table of values really quick just so you can see what's happening, and then we'll graph it and talk about how the one on the worksheet looks. So here's x, here's f of x, and remember we're rounding down. So if I put in 0, it's already a whole number. I don't have to round down. I get out 0. But if I put in 0.1, right, that's a decimal, I'm going to round it down to 0. And if I put a 0.9, I'm still going to round that down to the next integer, which is 0. Okay? Once I get to 1, that's an integer already, so my output is 1. I don't have to round it. If I put like 1.2, for example, I would round down to 1. If I put like a 1.7, again, just as an example, I would round that down to a 1. So anything between 1 and 2 gets rounded down to a 1. Anything between 0 and 1 gets rounded down to a 0. Okay? Once I get up to 2, that just stays a 2. And then 2.01, let's say, rounds down to a 2. And 2.99 rounds down to a 2. But as soon as I get to 3, I can stay at 3. So notice I only get out integers, 0, 1, 2, 3, and this always rounds down. And anything between 0 and 1 rounds down to 0. Anything between 1 and 2 rounds down to a 1. Anything between 2 and 3 rounds down to a 2. Let's see what that looks like graphically. Okay, so here's just a kind of spare piece of graph paper here. And this is the floor function. Okay, so if I put in 0, I get out 0. If I put in 1, I get out 1. If I put in 2, I get out 2, and so on. But the thing is, we got to think about the fractions, right, or the decimals. If I put in 0.5, I round that down to 0. If I put in 0.9, I round that down to 0. So what I have here is I have this line with an open dot here at the end. And this represents any time I put in a decimal between 0 and 1, I round down to 0. But as soon as I get to 1, I'm up at 1. Now if I choose anything in between 1 and 2, like 1.5, that rounds down to a 1. So any number between 1 and 2 rounds down to a 1. Any number between 2 and 3, like if I pick 2.9, that still comes out as a 2. 2.1 comes out as a 2. 2.5 comes out as a 2. So any number between 2 and 3, when I put that in, I end up at a height of 2. And we just continue that pattern. Anything between 3 and 4 is going to round to 3. If I put in a 3, I get out a 3. If I put in a 4, I get out a 4. But if I put in something between, like a 3.9 or 3.8 or 3.7, those all end up at 3. And we just keep kind of keeping this the staircase pattern, and that's why this is called a step function. Okay, so that's what the basic floor function looks like. Okay, there's a floor function, there's a ceiling function. They're both called step functions because they make this staircase kind of thing, and this is the floor function. Okay, so on your graph here, you have a version of the floor function. Right? It looks like the same thing we just graphed, only it's got a 2 in front of it. So it's going to look like this, but there's going to be a little bit of a difference to it. So let's think about what that would look like. Okay? Again, if you're ever stuck, you know, on a test, on a quiz, standardized test, whatever, and you're not sure what a graph looks like, you can always make a table and see, you know, if you choose enough points, you can kind of figure out what's going to happen here. So let's choose 0 for a second. If I choose 0 and I round it down, that's 0, and then I multiply it by 2, that's going to be 0 still. If I choose, let's say, 0.7, I round that down to 0, and then I multiply that by 2, and I get 0. What if I choose 1? Okay, well, I round it to a 1, and then I multiply it by 2. What if I choose 1.1? I round that down to 1, and I multiply it by 2. What if I choose 1.99? Well, I still round it down to a 1, and I multiply it by 2, and I get 2. Okay, what about 2? Okay, I don't have to round it. I put in 2, I round it to a 2, I double it, and I get 4. Okay, what about 2.3? Round it down to a 2, and then multiply it by 2. Right? So that extra multiply by 2, what it's doing is it's making it so my steps don't happen every single number. Like this one, the original, I have a step at 0, a step at 1, a step at 2. This has a step at 0, and then 2, and then 4. So it looks very similar to this guy, only my steps are like wider, or taller, I guess I should say. My steps are taller. Right? So I have this guy. If I put in 0, I get out 0. If I put in 1, I get out 2. If I put in 2, I get out 4, right? But now we got to talk about the in-betweens. So if I put in 0.5, I still get a 0. If I put in 0.9, I get out a 0. If I put in 1.1, I get 2. If I put in 1.9, I get 2. So anything in between 1 and 2 is going to end up as a 2. If I put in 2.3, I'm going to get out a 4. Right? So closed dot on the left, open dot on the right, just like we have over here, but my steps are wider apart. Okay. Now we can keep going here, but basically what we want is our steps to be, oops, put that in the wrong spot. Okay, so ignore that point. That's kind of what your function's going to look like, right? All right, now this guy does the opposite. It's the ceiling function. This is a round up function, okay? So the original function is going to look kind of similar, but that 3 is going to do something to it. So let's talk about the original, and then we'll go from there. So zoom out here. Okay, this was my floor function. My ceiling function looks really similar. And again, this is not the one on your worksheet. This is the basic version. But this is a round up. Okay. So if I put in 0, I don't have to round it. I just get out a 0. But if I put in a 0.1, I have to round that up to a 1. And if I put a 0.9, I round that up to a 1. And if I put a 1, I get out a 1 because I don't have to round it. Okay. If I put in a 1.03, that rounds up to a 2. 1.5 rounds up to a 2. I put in a 2, and I get out a 2 because I don't have to round it. Okay, so see, there's still the same steps, 0, 1, 2, but they're like in a different place. Anything between 0 and 1 will match up to a 1. Anything between 1 and 2 will match up with a 2. Okay, so if I put in 0, I get out 0. If I put in 1, I get out 1. If I put in 2, I get out 2. If I put in, oh, sorry. Not this graph. This is the wrong graph. I want to do that over here. This is just, this one's going to be a little bit different. Sorry, just the basic version. Whoops. All right. It's my Pizza Pie Cafe coupon to make my graph. All right, so sorry, once again, if I put in 0, I get out 0. I put in 1, I get out 1. I put in 2, I get out 2. Those are solid dots. Put in 3, get out 3. But the idea is I'm going to round up. So if I put in half, it's going to round up to 1. I'm going to be up here. If I put in 0.1, it's going to round up. If I put in 0.99, it's going to round up. So open dot on the left, line closed dot on the right. Okay. If I put in like 1.5, that's going to round up to a 2. A 1.9 will also round up to a 2. A 1.1 will round up to a 2. So open dot over here, line over, and so on. So this is, you'll notice it looks really similar, but they start in different places. This starts one higher than this one. Also, the dot is on a different side. The closed dot is on the right this time, and the open dot is on the left. Okay, so that's the basic version of that function. These are called step functions because it looks like stairs. This is the floor function. This is a ceiling function, but they're both in the broader category step functions. Okay, so now going over here. Sorry, I messed this one up already. It's 3 times round up. Okay, so remember what happened when I did 2 times round up? I had spaces, right? I had gaps. What it did is it transformed this function. This is like the parent function, the original floor function. This is a transformation of the floor function. Multiplying it by 2 made my steps farther apart. Okay, so this is a transformation of the ceiling function. So it's going to look like this, only when you multiply it by 3, well, what do you think is going to happen? That's for you to decide. Now, if you get stuck, you can always make a table, right? and you can figure it out. Pick a bunch of points. Also, don't just pick integers here. You got to pick decimals, otherwise you won't see what is supposed to happen because this is a rounding function. So you have to pick up some decimals as well. So let's pick one, and I'll get you started. Let's pick 1.1. Okay, 1.1 rounds up to 2, and then I multiply that by 3. 1.5 rounds up to 2, and then I multiply that by 3. 0.1 rounds up to 1, and then I multiply that by 3. So you see where this is going, right? If I put in 0, I round that to a 0, I multiply it by 3, I get 0. Okay, so you have steps here, but there's something different about the steps. So I'll let you finish that one up. I got you a good part of the way there. All right, so I hope that helps with piecewise functions and step functions as well. And remember, this section in your book is called special functions. Piecewise functions and how do I spell function? Piecewise functions and step functions are considered what we call special functions. All right, thanks guys.